For stationary motors rated 1/8 horsepower or less, the general requirement for the disconnect to be within sight of the motor and controller does not typically apply. The National Electrical Code, or NEC, provides specific guidelines regarding disconnect requirements for motors, and these guidelines vary based on the motor's horsepower rating and application. A disconnect is a device used to isolate a motor from its power source for safety during maintenance or repair. The purpose of having a disconnect within sight of the motor and controller is to ensure that anyone working on a motor can visually verify that the power is disconnected, preventing accidental energization. This is a critical safety measure for larger motors where the potential hazards are more significant. However, for very small motors such as those rated 1/8 horsepower or less, the NEC recognizes that the risk associated with accidental energization is substantially lower. Consequently, the requirement for an in-sight disconnect is often relaxed. This is because the energy involved is minimal and the potential for serious injury is reduced. The NEC guidelines for motor disconnects are primarily found in Article 430. Specifically, Section 430.102 addresses the location of disconnects. It generally requires the disconnect to be within sight from the motor and the driven machinery location. However, exceptions exist for motors that meet specific criteria, such as being fractional horsepower motors. It's important to note that while the general rule of an in-sight disconnect may not apply to these small motors, other safety measures and disconnect requirements still need to be met. Firstly, the motor must still have a disconnect that is readily accessible. This means that the disconnect should be located in a place where it can be easily reached without requiring tools to open enclosures or climb over obstacles. Secondly, the disconnect must be capable of being locked in the open position. This lockable disconnect ensures that the motor cannot be inadvertently energized while someone is working on it. The locking mechanism provides an additional layer of safety, especially during maintenance and repair procedures. Thirdly, the disconnect must be suitable for the voltage and current requirements of the motor. This means that the disconnect must be rated to safely interrupt the motor's full load current and withstand the available fault current at the installation location. Using an appropriately rated disconnect ensures that it can effectively de-energize the motor under both normal and fault conditions. Fourthly, the installation must comply with any local amendments or requirements. Local jurisdictions may have additional regulations or interpretations of the NEC that apply to motor disconnects. It is essential to consult with local electrical inspectors or authorities to ensure that the installation meets all applicable codes and standards. Fifthly, even if the NEC does not explicitly require an in-sight disconnect, it is often a good practice to install one whenever feasible. Having a disconnect within sight provides an added level of safety and convenience, especially during maintenance and troubleshooting. It allows workers to visually confirm that the motor is de-energized and prevents misunderstandings or errors. Sixthly, it's crucial to understand the specific application and environment in which the motor is being used. In certain industrial settings or hazardous locations, additional safety measures may be required, regardless of the motor's horsepower rating. These measures could include explosion-proof enclosures, intrinsically safe circuits, or other specialized equipment. Seventhly, it is important to consider the type of motor controller being used. Motor controllers range from simple on-off switches to complex electronic drives. The type of controller can affect the disconnect requirements and the need for additional safety features. For example, a motor controller with built-in overload protection may reduce the risk of motor failure and the need for frequent maintenance. Eighthly, regular inspections and maintenance of the disconnect and motor control system are essential to ensure continued safety and reliability. Inspect the disconnect for any signs of damage, corrosion, or overheating. Test the disconnect's operation to verify that it properly interrupts the power supply. Clean and lubricate the disconnect mechanism as needed to ensure smooth operation. Ninthly, it is also important to train personnel on the proper procedures for disconnecting and working on motors. Training should cover the location and operation of the disconnect, the use of lockout/tagout procedures, and the potential hazards associated with working on electrical equipment. Properly trained personnel are more likely to follow safety protocols and prevent accidents. Tenthly, if the motor is part of a larger piece of equipment or machinery, consider the overall safety requirements of the equipment. The equipment manufacturer may have specific recommendations or requirements for motor disconnects and safety interlocks. Integrating the motor disconnect into the equipment's safety system can provide an additional layer of protection. 11thly, it is important to maintain accurate documentation of the motor disconnect and control system. This documentation should include wiring diagrams, equipment specifications, and maintenance records. Accurate documentation can help with troubleshooting, maintenance, and future upgrades. 12thly, the specific interpretation of the NEC can vary depending on the authority having jurisdiction, or OJ. The AHJ is the local electrical inspector or code official who is responsible for enforcing the electrical code. It is essential to consult with the AHJ to ensure that the installation meets the specific requirements and interpretations. 13thly, consider the potential for future changes or modifications to the electrical system. If there is a possibility that the motor will be upgraded or replaced in the future, it is a good idea to install a disconnect that is suitable for a larger motor. This can save time and money in the long run by avoiding the need to replace the disconnect later. 14thly, the disconnect should be clearly labeled to identify the motor it controls. This labeling helps prevent confusion and ensures that the correct disconnect is used when working on the motor. The label should be durable and easy to read, even in dimly lit or dirty environments. 15thly, consider the environmental conditions in which the motor and disconnect are located. If the environment is corrosive or hazardous, use a disconnect that is specifically designed for those conditions. This will help prevent damage to the disconnect and ensure its continued safe operation. 16thly, if the motor is located in a remote or difficult to access location, consider using a remote-controlled disconnect. A remote-controlled disconnect allows the motor to be de-energized from a safe distance, which can be especially useful in hazardous or inaccessible areas. 17thly, ensure that the disconnect is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps protect against electric shock and equipment damage. The grounding conductor should be sized appropriately for the motor's full load current. 18thly, it is also important to consider the coordination of the disconnect with other protective devices in the electrical system. The disconnect should be coordinated with circuit breakers or fuses to ensure that a fault current is properly interrupted. This coordination helps prevent damage to equipment and minimizes the risk of electrical fires. 19thly, if the motor is part of a critical system such as a fire pump or emergency generator, consider using a disconnect with redundant features. A redundant disconnect can provide backup protection in case the primary disconnect fails. This can help ensure that the critical system continues to operate even in the event of a component failure. 20thly, it's crucial to remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest requirements and best practices for motor disconnects. Regularly review the NEC and consult with qualified electrical professionals to ensure that installations are safe and compliant. In summary, while the NEC often relaxes the in-sight disconnect requirement for stationary motors rated 1/8 horsepower or less, it is essential to adhere to other safety measures and disconnect requirements. These include ensuring a readily accessible, lockable, and appropriately rated disconnect. Additionally, local codes, specific applications, and environmental conditions should be considered. By following these guidelines, you can ensure the safe and reliable operation of small motors and protect personnel from electrical hazards. Always consult the latest edition of the NEC and local regulations for the most accurate and up-to-date information.